Hey, hello student. So today's session is on upthrust. So this session is mainly for class 9 ICSE student. So I believe that this will really help you to cover the chapters on upthrust, the condition of floating, and also about the liquid pressure. Okay. So first I have shared a slide where you can see that two forces I have mentioned. One is W and the FB. W is the weight of a body acting downward, and Fb is the force of buoyancy acting on the body which is acting upward. Okay. So force of buoyancy and the weight. So what is force of buoyancy? This is the upward force given by the any liquid. That liquid may be water and whatever. So they are giving the upward force, and this Fb depend on the volume of the displaced water and density of the liquid. So here if you see the screen, Vd is the volume of the displaced water and rho L is the density of the liquid. Okay. So now I'll show you what is displaced water. Whenever we are submerging some object inside the water, it is taking some volume, right? So that volume is that amount of water getting displaced from that position. So that's called displaced water. Okay, next is the weight of the object. So weight W is equal to mg, m is equal to volume of the object into mass, into density, right? So here in the left side, V is equal to the total volume of the object, rho is the density of the object. Okay. Now during the floating, as per the condition of floating, the upward force Fb should be greater than equal to downward force weight. So if we equal W is equal to Fb, so we are getting that V rho g is equal to Vd rho L g. Okay. So this is the equation. Most of your numerical will be solved with this equation. So whatever the questions are, if you see the solution, it will go in the same direction. Okay. And the amount of volume, you'll get a lot of questions, right, where part of the volume is outside liquid, part inside. Like if you see that total volume V, if half of the volume outside water, then volume of the displaced water will be V by 2, right? Because V by 2 is the remaining volume. If 1 by 3 volume is out of water, that means 2 by 3 volume is inside water. So displaced water volume will be 2 by 3 into V. Okay. So this way, and also I'll just show you some bit hands-on on it. Okay. So let me go to the screen now. So where I'll be showing you the experiment and the live demonstration on it. Like if you see, this is the water here, and inside water this is the level of the water. Okay. And here we are having an upthrust force, which is the inbuilt upthrust force given by the water. Now if I take a coin here, if I take a metal body, if I place it, it will just sink. If I again one more metal body, if I place it, it will just sink. So what happened, that the downward force weight, is greater than the upward upthrust force here, right? Now let's take, this is an wood material. So if I place it, if you see, this wood is floating, right? So this wood is floating. That means for this wood, the upthrust force balancing the downward force. Okay. And this is few part of the wood is out of the water. Now if I take this wooden bell, cricket bell, if I put here, what happened, that it will also float, and few part outside the water, few part inside the water, right? So whatever the part, and also the level of this water is going up. If I put one more object here, so what happened, that this level up, that means water getting displaced. So more things you will put in here, so water height will be raised. That means, so this is the feelings of the displaced water, right? So for this wood material, it displaces few part of the wood, and let's say 1/2 of this wood is inside water, right? So Fb will be 2/3 volume multiplied by the density of this liquid water and the G. So this is FB, right? So FB is very important here, okay, to understand what is FB. So this FB is acting upward. If I just marked here, FB, force of buoyancy acting upward and weight acting downward, okay. So dear students, so this is very important, that condition of floating, weight will be is equal to FB. Or let's say if you take a thermocol, it most of the part is going out of the water, right? So for thermocol, FB is far more higher than the downward weight, okay, right? So I hope you understand. So you can do the same in your home, okay. So to get, now again, if I put this kind of object here, right? So this will again float, and if you see clearly here, for these objects, few part inside water and few part outside water, right? So whatever inside water, that is the you know this VD, the volume of the displaced liquid, and FB depend on this displaced volume of the displaced liquid, displaced water by the object, and rho L is the density of the liquid. So the more the density of the liquid, more the upthrust it will give. That's why in the sea water is having more upthrust force than the the plain water, like, or the distilled water, because sea water the density is more. So more the density, high density liquid, it will be having more upthrust force, right? And also the volume of the displaced water or displaced liquid is also very important. For this metal, what happened that its density is higher and also its displaced volume is lesser. So it's not getting the the proper upthrust force to float itself, right? Okay. Now let's come to here. If you see that this is weight is equal to weight means V rho g, right? V rho g. So V is the volume of the object, total volume, right? And this is the density of the object, and this is the acceleration due to gravity. Here FB means volume of the displaced water, density of the liquid, and G. So if you equalize the G, you will be omit. So this is very important equation I am telling you. Most of the, almost every sums will be solved by this one, okay. So just go through the session, the chapters, and if you are facing any issues, you can directly call to my number also, and just text me. I'll give you the the solutions, right? So, and also in the next session, I'll show you how to solve the numerical of this part, right? So you go through it, and I'm telling you, this is very important chapters for your coming term one exam, most of the schools, ICSE. So this will be very important, lots of questions. And also in next session I'll describe that relative density. Relative density is also having a relation to this upthrust force. Relative density means this comes from this upthrust force itself, right? And also apparent weight, like whenever these are the objects, right? So they are floating. So if they are in air, they their upthrust force is very important. So it seems that the weight is apparently decreased. That's called apparent weight. Like whenever you are in the swimming pool, what happens, that weight acting downward, FB acting upward, right? So W minus FB, that is the apparent weight. So FB is the loss factor of your weight, loss of your weight. You can say like that, okay? Thanks for watching the session, okay? Please follow my other session, and I believe it will really help you for your coming term 1 and term 2 exams, okay? Thank you.